Hi, for this recording, I'm going to show you how to evaluate the following limit using the LHopital rule. Limit of x approaching 1, x cubed plus x squared minus 5x plus 3 divided by x cubed minus 7x squared plus 11x minus 5. Now, to evaluate this limit, you must recall what is LHopital rule. LHopital rule is, you can refer to David Brandon text page 238. Say consider a limit x approaching a f of x over g of x. Suppose this is of the form 0 over 0. That is, limit of x when x approaching a is 0 is equal to limit of gx when x approaching a. Such as limit of x approaching 0 tangent 2x over sin x, where a is equal to 0 now, fx is tangent 2x, gx is sin x. Now in this case, the general statement says that if f and g are differentiable on an open interval containing the point C at which f of C and g of C equal to 0, and then limit the x approaching C, f of x, g of x exists, and is equal to limit of x approaching C, f prime of C over g prime of C, provided that the last limit exists. So understanding this, then you can approach the solution of this problem now. So we are going to call the numerator f of x, the denominator g of x. So let f of x equal to x cubed plus x squared minus 5 plus 3. G of x equal to x cubed minus 7x plus 11x minus 5. Then you find that f of 1, in this case, putting x equal to 1 inside there, you'll find that 1 plus 1 minus 5 plus 3 equals 0. G of 1 is 1 minus 7 plus 11 minus 5, which is also 0. And we know that f of x and g of x are differentiable at x equal to 1. And because we have a 0 over 0 case, just like the LHopital rule I mentioned, a 0 over 0 case. So we need to find out, we can find out what is f prime of x now. F prime of x equals 3x squared plus 2x minus 5. And g prime of x is 3x squared minus 14x plus 11. Now using the LHopital rule, we find that limit of x approaching 1, f of x, g of x, is limit of f prime x over g prime x at x approaching 1 now, and which is equal to limit of x approaching 1, 3x squared plus 2x minus 5, and 3x squared minus 14x plus 11. Now notice that this is again a 0 over 0 case, because if you notice that f of 1, f prime of 1 is equal to 3 plus 2 minus 5, which is 0, and g prime of 1 is equal to 3 minus 14 plus 11, also 0. And we know that f prime of x and g prime of x are differentiable on an open interval from minus infinity to infinity. Alright, and we also know that therefore, and f double prime of x is equal to 6x plus 2, and g double prime of x is equal to 6x minus 14. So according to the LHopital rule again, we know that limit of x approaching 1, f prime of x over g prime of x, because this is again a 0 over 0 case, just like before, f prime of 1 over g prime of 1, you have both case of 0 over 0 case. Therefore, we can apply LHopital rule again to say that, okay, the limit of x approaching 1, f prime of 1, g prime of 1 is equal to limit of x goes to 1, f double prime of x, g double prime of x, which is equal to limit of x approaching 1, 6x plus 2 over 6x minus 14. Now, you notice that as f double prime of x and g double prime of x are continuous at the point 1 since they are polynomial, and f double prime of 1 is equal to 6 times 1 plus 2 is 8. G double prime of 1 equals 6 times 1 minus 14 is minus 8. Therefore, by the combination rule now, by combination rule or continuity of f double prime g double prime of x, we know that limit of x goes to 1, 6x plus 2, 6x minus 14 is equal to 8 over minus 8, which is minus 1. Therefore, we conclude that our original problem, limit of x goes to 1, f of x, g of x, eventually this is equal to the limit of x goes to 1, f prime of x, g prime of x, which is eventually equal to limit of x goes to 1, f double prime of x, g double prime of x, and which is equal to f double prime of 1, g double prime of 1, as we divide, you get 1 over minus 1, which is minus 1. Okay, so this is almost the end of the solution. What I'm going to show you now is how to use classback to find the solution. So I'm going to call up classback now. So let's call up the classback. So, alright, so I'm going to go to the main program of classback, and I'm going to clear the screen. I did clear screen, and then I'm going to find the limit. Go to the keyboard, and then I play 2D, calculus, limit of x goes to 1. Then over here, I'm going to do a fraction. Okay, so fraction, I'm going to x power 3. Alright, the problem, if you remember, f power 3 and plus x squared minus 5x. Okay, so I move down, plus x squared, okay, and then minus 5x plus 3 over x cubed, alright, minus 7x square, move down, plus 14 plus 11x minus 5, right? Plus 11x minus 5, so plus 11x minus 5. So now I just execute and find the answer. It says the answer is minus 1. Alright, so this is the end of the recording.